Stephen William Hawking was born on January 8, 1942, in Oxford, England. His parents were Frank and Isabel Hawking. They loved learning and they talked about ideas in their home. Stephen had two younger sisters, and they grew up in a house where books and conversations were always around. As a child, Stephen liked to learn, but he was not a model student at first. He liked to play tricks, make jokes, and take things apart to see how they worked. He loved making little boats and letting them float in the canal near his house. He liked to watch the boats move and think about why they moved that way. When the family moved to St. Albans after World War II, Stephen went to school and then to St. Albans School. He was very bright, but he sometimes found school easy and boring. He loved math and science best. He liked to imagine how the world worked, from tiny things to very big things like planets.
Stephen was not always a good listener in class. Teachers saw him as lively and sometimes naughty. His friends called him a prankster. He would hide toys or set up funny scenes to make people laugh. But behind the jokes, Stephen had a serious curiosity. He read books about space and stars, and he spent hours thinking about big questions. How did the universe begin? What are black holes? How do stars and planets form? At home, Stephen's parents encouraged his interest in science. They bought him books and let him explore experiments. His father worked in medicine but loved science as a hobby. He and Isabel often encouraged conversation and ideas around the dinner table. Those conversations helped shape Stephen's thinking and his desire to study. When he was a teenager, Stephen decided to study physics at university. He won a place at University College, Oxford. At Oxford, he studied natural science and then physics. The college life was relaxed. He loved talking with friends late at night and thinking about problems. He also met people who cared about similar ideas. At Oxford, Stephen grew close to some friends who liked jokes and serious talks in the same hour. He also built a habit of working quietly and deeply on tough problems. He was not afraid of hard questions. He wanted to try to answer them.
After Oxford, Stephen moved to Cambridge to study more. He went there to do research, to ask harder questions, and to work with other scientists. This move was important. Cambridge would be the place where he spent most of his life and where he would do his biggest work. However, around the age of 21, Stephen's life took a hard turn. He started to find it difficult to walk. He felt tired and weak. Doctors examined him and said he had a disease that affected his nervous system. The disease was amyotrophic lateral sclerosis, often called ALS or motor neuron disease. The doctors told him he might live only a few years. This news was shocking and sad. Stephen did not give up. He kept working, learning, and thinking. He used his strength of mind to face the challenge. Even as his body changed over time, his mind stayed active. He continued studying the universe, asking how it began and what laws of nature must be true.
In the early years after his diagnosis, Stephen married Jane Wilde. She supported him, and they had 3 children together. Jane helped create a stable home so Stephen could work. Friends and colleagues at Cambridge also helped him. He continued to study and to write, even when he had to learn new ways to do his work because his body became weaker. Stephen's early life shows how a curious child, a lively student, and a quiet thinker can grow into a person who keeps asking big questions. His early years were full of learning, jokes, friends, and then the hard news of illness. Yet he kept working, and this resilience shaped the rest of his life.
After Oxford, Stephen went to Cambridge for his graduate studies. He worked on the theory of the universe, trying to understand the big rules that govern space and time. He read many books and papers and met other young scientists who loved the same puzzles. During these years, Stephen worked on a subject called cosmology. Cosmology is the study of the whole universe, how it begins, how it changes, and how it might end. The field was full of mystery. Many people thought the universe was simple, but Stephen saw many new questions that no one had clear answers to. One important idea was that the universe began with a very small, very hot point. Scientists called this the Big Bang. Stephen studied what happened at the very beginning when space and time were tiny and the rules of physics acted strongly. He used math to understand how gravity and other forces worked at that time.
In his early research, Stephen worked on the behavior of black holes. A black hole is a place in space where gravity is so strong that not even light can escape. Stephen asked, what happens at the edge of a black hole? Can we describe the inside and the outside with the laws of physics we know? He used math to show how black holes might have their own rules and that they might be simpler than we thought. At first, he worked with friends and mentors like Dennis Sciama and Roger Penrose. Penrose had already used clever math to show that black holes could exist and that they might come from the collapse of large stars. Roger and Stephen talked a lot and wrote papers that helped the scientific world understand how gravity and spacetime behave. In 1970, Stephen and others showed something important. When the universe begins or when a star forms a black hole, the math shows a point of infinite density called a singularity. A singularity is a place where our usual rules break down and we need better ideas. This idea made people stop and think. The Big Bang and black holes might be connected by deep math.
As his disease grew slowly worse, Stephen continued to work. He used a wheelchair and, later, other tools, but his mind kept moving fast. He learned to speak differently and to work with assistants who helped him write and do math. He wrote papers and gave talks. His ideas began to attract attention. Stephen also enjoyed teaching students and talking about science in public. He had a way of making hard ideas seem simple and exciting. He could use pictures and simple words to help people see strange ideas about space and time. In the 1970s, Stephen discovered an idea now called Hawking radiation. This was a surprise. Black holes were not completely black. According to his calculations, black holes could slowly lose energy and particles over time. This meant that black holes could evaporate and slowly disappear. The idea connected the world of gravity with the world of quantum theory, which describes tiny particles.
Hawking radiation was a big step. It showed how two very different parts of physics might talk to each other. The discovery made Stephen famous in the scientific world. It also gave him a new picture of how the universe works. Even the darkest, most hidden places have a strange activity at the quantum level. During these university years, Stephen also began to write for a wider audience. He wanted people beyond science to know about the cosmos and the new ideas that were changing our view of the universe. His goal was to make difficult ideas clear and to share the wonder of the sky and the stars.
In 1988, Stephen wrote a short book aimed at general readers. The book had the title, A Brief History of Time. In it, Stephen explained many of the ideas he had worked on in a simple and friendly way. He wrote about the Big Bang, black holes, time, and the search for a simple theory that can explain everything. The book became a surprise success. People outside science bought the book and read about the strange and beautiful rules of the universe. The book stayed on bestseller lists for many weeks. Stephen became a public figure. He appeared on television and gave interviews. He spoke in plain language, often smiling, and he used simple images to explain complex ideas. People admired him for many reasons. He had a sharp mind and could explain tough ideas simply. He also had a public presence that made science feel human. He did not only speak to scientists in narrow journals, he spoke to the public, to students, and to people in many countries. His fame also brought attention to his personal life and health. People noticed how he moved in a wheelchair and used a voice synthesizer later. They saw how he used technology to speak and to work. He became a symbol of a brilliant mind living with a severe disability.
Stephen used his fame in other ways. He helped raise money for research and for hospitals. He talked to leaders and to the public about science and the future. He wrote more books and gave lectures across the world. His clear, calm style helped many people feel curious about the universe. But fame did not change his working habits. He kept writing technical papers and thinking about the deepest problems. He still worked with students and other scientists. He used his public voice to ask big questions. Can we find a single rule, a unified theory that explains everything? How do the smallest particles and the largest galaxies connect? Even with fame, Stephen remained focused on work. He loved to see a young scientist get a new idea or a student find a solution that moved the field forward. He kept his curiosity and his desire to explain the world.
Stephen's work included many ideas that were hard to explain. Here, in simple language, are some of the main ideas he helped the world understand. The Big Bang. Stephen and others believed the universe was not always the same. Long ago, the universe was much smaller and much hotter. It then grew, cooled, and formed stars and galaxies. The study of the Big Bang asks how the universe began and how it changed with time. Black holes and singularities. A black hole is a place where gravity is very strong. Stephen showed that under the right conditions, the same math that describes the Big Bang also leads to singularities inside black holes. These are points where our current rules stop working and new ideas are needed. Hawking radiation. Stephen discovered that black holes are not completely black. Tiny particles appear near a black hole and can escape as radiation. This means black holes can slowly lose mass and might fade away over time. This surprising idea links gravity with quantum physics. The arrow of time. Time seems to move in one direction, from past to future. Stephen looked at ideas about why time flows and how the laws of physics allow or limit certain directions of time. He helped people think about how the beginning of the universe affects the flow of time we feel. A unified theory. Many physical laws work well in different situations. One large goal is to find a single theory that connects gravity with quantum physics. Stephen spent much of his life thinking about this problem and how to test ideas that might lead to a simple, elegant law. Stephen's skill was to use strong math when needed, but to try to explain the meaning of his math in clear words and pictures. He used models, thought experiments, and simple comparisons to show how a black hole might behave, or how the early universe changed. Even when ideas were hard, Stephen used everyday words and clear images. He showed how seemingly strange ideas can be understood step by step. His books and talks often used stories and simple examples so people could feel the wonder and the challenge of science.
Science was a large part of Stephen's life, but his life included many personal moments, friendships, and family matters. Early in his career, he married Jane Wilde, who became a steady partner. They had 3 children, Robert, Lucy, and Timothy. Jane kept a strong role in the family, supporting Stephen as his health changed and his workload increased. As Stephen grew more famous and his condition progressed, family life became complex. He relied on care and help to move around and speak. Family members, nurses, and friends helped him with daily life. At times, the pressure on the family was large, and relationships changed. Later, Stephen's marriage to Jane ended. He married Elaine Mason for a time, and that marriage also ended in divorce. These personal events were part of a life lived in public, and sometimes they attracted gossip and strong feelings. Stephen also had close friendships with many other scientists. He often worked with students and younger researchers. He loved lively debate and clear thinking. Friends said he had a dry sense of humor. He liked a quick joke and a clever idea. He could be warm, impatient, playful, and very direct.
The disease that affected Stephen's body remained a central challenge. He used a wheelchair and needed help for daily tasks. He lost the power to speak and later used a speech synthesizer to talk in public. This machine gave him a voice that many people recognized. He used technology to continue his work and to travel around the world. Despite physical limits, Stephen kept a busy schedule. He traveled to give lectures, he appeared on television shows, and he wrote books and papers. He understood how to use the media to explain science simply. He also loved to attend events with students, to ask questions, and to encourage new thinking. At times, public life and health issues created tough moments, but Stephen often responded with humor and a calm way of facing things. He liked to remind people that his mind was free to think even when his body was limited. He said that the mind can be independent of the body, and he used that belief to keep working and to stay curious. In his later years, Stephen continued to ask big questions. He wrote more books for the public and made science visible to millions. He spoke about the need to think carefully about the future, about the Earth, about technology, and about how we should use our knowledge. He often warned about possible dangers, like the misuse of advanced technology. He said that as machines and computer systems become powerful, people need to think about the right ways to use them. He also spoke about the importance of science to help solve problems such as climate change and energy. Stephen supported research in cosmology, particle physics, and the search for a unified theory. He worked on new ways to understand the early universe and the rules that govern space-time. He helped young researchers by giving advice and by being open to new ideas.
He also became a symbol of human courage for many. People around the world admired how he lived with a hard disease and still kept working at the highest level. His life showed that limitations of the body need not stop the life of the mind. His fame helped raise funds for research into motor neuron disease and for technologies that help disabled people. Stephen used technology to communicate and to work. His use of the speech synthesizer became a sign of how technology can give voice to someone who cannot speak. He also took part in television programs and films that brought science to wider audiences. He appeared in documentaries and even in popular shows where he explained ideas in clear and human terms. His influence extended beyond science. He spoke on ethics, on how we should treat each other in a world of new machines, and on the importance of curiosity and exploration. He once said that reading and thinking are among the most valuable things a person can do, and he urged young people to ask big questions.
Stephen Hawking passed away on March 14, 2018. When he died, people around the world remembered a life of brilliant thinking and public courage. They remembered a man who changed how we see black holes, how we think about the Big Bang, and how we connect very small particles with the large world of stars and galaxies. Stephen's legacy is not only in the theorems and papers he left behind, it is also in the way he spoke to the public and in the many students and researchers he inspired. Many people who never studied physics read his books and tell friends about black holes and the beginning of time. He made science feel human and full of wonder. There are simple lessons from his life that any listener can take home. First, keep curiosity. Stephen never stopped asking why and how. Second, work with others. He collaborated with many scientists and learned from them. Third, do not let limits stop thought. Even when the body is limited, the mind can explore far beyond. Fourth, explain ideas clearly. Stephen worked to make complicated thoughts simple so more people could join the conversation.
After his death, scientists continued to study the problems Hawking worked on. New observations, new experiments, and new computers helped test ideas about black holes, cosmic origins, and the nature of space-time. Stephen's ideas remain a guide and a challenge. Find better ways to explain nature and make the laws that connect the very large and the very small. His public image also inspired support for research on motor neuron disease and on tools that help disabled people. Many technologies that assist daily life continue to improve because people saw how useful these tools can be.